And everyone, welcome back to Decode with Sahil. So today we are going to solve the problem maximum product subarray. So let's dive right into the problem. So given an integer array nums, we need to find a subarray that has the largest product and return the product. So what is asked in the question is, like suppose we are given a nums array. So let's consider the first example. So we are given 2, 3, -2, and 4. So we need to find a subarray. Subarray means the portion of the array that is continuous. Like 2 comma 3 is a subarray, 3 comma -2 is a subarray. Like 2 comma -2, it is not a subarray. Subarray needs to be continuous, right? So, uh, so we need to find a portion of the subarray that has the largest product. Okay. So if we see this example, so if we do 2 into 3, it is 6. Okay. 2 into 3 into -2, so it becomes negative. It is not large, right? -2 into 4, it is also negative. 2 into 3 into -2 into 4, that also becomes negative. So the largest product is 2 into 3, that is 6, right? So on the basis of this, what things we can conclude, like what things we can figure out. So first thing, if the array has all the positive elements, right? All the positive elements, then in this case, we can take all the elements of the array and include them in the answer, right? If it would have been a +2. Then we could have taken 2, 3, 2, and 4, right? And multiplied all those, and that could be our answer, right? Similarly, if the array contains even number of negative elements, right? Even number of negative elements, then also we can include all the elements of the array, right? Because if we multiply two negative numbers, that becomes a positive number, right? Okay. Another thing. Suppose we have a zero in between, right? And if we include that zero, so that will make our product negative. Product zero, right? Because anything multiplied by zero is a zero. So we don't want to include that. So we have to take care of that case as well. Okay, so I've done enough talking. So let's walk right into the code. So what can we do to solve this problem? So and it is also mentioned that the product of any subarray of nums is guaranteed to fit in a 32-bit integer. So we can take integer for our answer. Okay. So what I'll do is, and I don't want to do a nested loop because that will result in a n square complexity. So I'll try to do the solution in a single pass. Okay. So what can we do? So we can take a prefix and a suffix product as we did in our previous problems as well, right? So we can take a prefix product, we can take a suffix product. Okay. And we can keep on checking all of that. So for a particular index, we can take the prefix product, we can take the suffix product. And whichever is greater, we can store that in the answer. And if we move that iteratively, at the end, we have the answer variable uh, will be storing the maximum value, right? I think I know that this might be a bit complicated for you, but let's jump into the code so that you would understand the things better. And then later on, we'll try it in the code as well. All right? Okay. So what we can do is that we can take a length variable that will store the length of the array because we'll need it later. Now, in order to store the prefix product, we can take a variable L that will store the prefix of the all the elements that are to the left of that particular index. So we can initialize it to 1. Okay. Similarly, we can do it for right, and we'll initialize it to 1. Now we need an answer variable that will be storing our answer. Okay. So the answer. So what should it be initialized with? So we can initialize the answer variable with the first element of the array. For now, let us suppose this is our answer. All right. Now I'll start iterating over the array. Okay. So I'll start with int I equals to 0, I less than n, I plus plus. All right. Now, as I was talking about earlier, that if we encounter a 0 at any point, okay, so if we multiply anything with 0, it will result in 0. And we don't want that because it will give us the incorrect answer. So anytime we encounter a 0, we'll change it to 1 because anything multiplied by 1 is the value itself. Okay. So that will help us avoid that zero error, right? So if L is zero, then in that case, so I'm using a ternary operator here. So if L is zero, I'll change it to one. Otherwise, I'll make it L only. Okay. Similarly for R, if R is zero, then in that case, I'll change it to one. Else it would remain as R only, right? So this has solved a zero case, right? Like if L or R becomes zero, right? So this has solved this case. Okay. Now I have to show the prefix product, right? So for prefix product, what should I do? So I need to multiply the elements to the left of that particular number, right? So what I'll do is L, I'll update the L. L is storing the prefix product. R will be storing the suffix product. So L into is equal to nums of I, right? So what does it mean? Like if we encounter a 2 in here, okay, L is currently 1. So 1 into 2, that will be 2. So prefix product until this element is 2, right? Same for suffix product. What will I do for suffix product? So suffix product means now I have to calculate the product from the end. Don't consider it I have to do it from here. Consider it from the end. Okay. So necessarily I have to take the last index. So I'll do R into multiply is equal to nums of n minus 1 minus I. Why did I do that? So n, if you consider the first example, n is equal to 4, right? Nums dot length is 4. So n minus 1 minus I. N minus 1, why did I take n minus 1? Because array doesn't need to get out of bound, right? So 4 minus 1 is 3 minus I. So I is 0 in this case. So then nums of 3. Nums of 3 is necessarily a last element. So I need to pick the last element. So now this is storing the product from the starting index. This is storing the product from the last index, right? And now in order to get the answer, it should be the maximum value from left and right, right? So math dot maximum. Okay. And it would be math dot maximum of left or right. Or if any of those value isn't maximum, like if both of the values are negative. So in that case, our original answer would be the answer, right? Which we have taken earlier, right? And we'll return the answer. So what I'll do is I'll quickly run the code to see if it has any errors, and then we'll try run the code together. Okay, it's accepted. All right. So it's working perfectly fine. So now I'll write in the code for you so that you will understand better. So I'll take this example. Okay. So now we are at index 0. Okay. Currently answer is having the value 2. Okay. Now prefix product. L becomes, so I'll type in the iterations as well. Iteration 1, L, R, and answer. Okay. So now what L would become? L would be 2 into 1. So L would be 2. R would be 1 into 4. So it would be 4. Earlier, the answer is 2 because it was the first index. Now, if we get into this condition, it would be math.max left comma right or answer. So our answer was 2, but the maximum value was R. So answer is 4 for now. Now, if we come to iteration 2, so now we encounter a 3. So now L into current element 3. So L becomes 6. R 4 into minus 2. So R becomes minus 8, right? And answer math.maximum left comma right comma answer. So it would become L is greater than answer. So it becomes 6. Now in iteration 3, it becomes minus 2. So 6 into minus 2, that is minus 12. Okay. Minus 8 into 3. So that becomes minus 24. Now answer maximum of left comma right comma answer. So L and R both are negative, but the answer is 6. So it remains 6 only. Now in a final iteration, iteration 4, L into the current index. So minus 12 into 4, that is 48. And minus 24 into 2, that also becomes minus 48. Now answer equal to maximum of this, comma answer. So it is answer. So now after all the iteration, we have the answer as 6. So then I would return the answer and it comes as 6. So which is the answer. So I hope you got the logic. Try it yourself. Try thinking of the approach. There are other approaches as well to this problem. You can use a two-pointer approach as well to solve this problem in n-time complexity. So good luck on that, and feel free to drop in comments so that I would include something you want me to include, and I'll see you in the next video.